Assalamualaikum warahmatullahi wabarakatuh to Dr. Fazinda and Dr. Hashima. My name is Sarah Izzaty binti Abdul Malik with metric number DB21008. Today, I am going to present my project title, Android Application Development for Science Learning Unit 9, States of Matter, Year 5. So, let us begin. The title of my project is Development of a 2D Animation Learning Application for the topic of matter, which is theory for Year 5 students. I started this project based on real issues observed in classrooms, such as many students struggle to understand the concept of matter because it is quite abstract. Teachers also admitted that conventional methods such as nodes and static images are not very helpful. Therefore, I developed an interactive learning application using the ADDIE model and based on learning theories such as constructivism and cognitive load theory and also dual coding theory. The main goal of this application is to improve students' understanding and interest in this topic through a visual and user-friendly approach. For my problem statement, I can state three kinds of problem, which is the first one is the concept is too abstract and cannot be easily seen with the naked eye. So this difficulty comes from the nature of matter, which we cannot be directly observed. As a result, students may develop misconceptions about this topic because the topic is too difficult for them. Secondly, the existing applications are not suited to the needs of students, which mostly the application that I found on the internet will contain fake content and include notes that do not support student understandings. What I mean is that most applications on the internet do not align with the Malaysian science textbook content or follow the DSKP, which is Document Standard Curriculum and Pentaksiran. Lastly, students often forget and find it difficult to remember content related to states of matter or Jure because the teaching materials are not engaging enough. For an example, the textbook alone is not effective as it requires someone to guide or explain the content at home in order for students to fully understand the topic. There are three objectives for my project, which is the first one is designing 2D animation Android applications learning unit 9 science subjects year 5. The second is developing 2D animation Android applications learning unit 9 science subject year 5. And the third is testing the functionality of the 2D animation Android application learning unit 9 method in year 5 science subjects. For my scope project, there are three things that I really focused on. The first one is this application was developed specifically for Year 5 students who are learning science. The focus of the application is one of the key topics in the Year 5 students syllabus, which is Chapter 9, States of Matter, which is GRAM in Malay. So to build this application, I use several software tools including Adobe Animation, Adobe Animate for animation, Adobe Illustrator, and Adobe Photoshop for designing the graphics, and CapCut for video or audio editing. Next, I applied three learning theories in the development of my application to make sure it is effective and suitable for students. The first theory is the cognitive load theory. This theory focuses on reducing unnecessary information so that students can focus better and understand the key content without feeling overloaded. The second theory is the dual coding theory. I applied this by combining both visuals and text to help students remember the information more easily. When students see and read something at the same time, it improves their understanding. This third theory is constructivism. This theory supports learning through experience and discovery. So I designed the app in a way that encourages students to explore and interact with the content on their own rather than just receiving information passively. By using these three theories, I aim to create a learning application that is clear, interactive, and effective for Year 5 science students. So before developing my application, I have referred to several previous studies to support the use of 2D animation in education. So I will share to you the three research findings that are closely related to my project. So these studies show how animation can improve students' understanding and motivation, especially when dealing with abstract concepts like the topic of states of matter, which is jirim in Bahasa Melayu. So the first study is by Wahyuni et al. In 2021. Wahyuni stated that they found that using 2D animation in physics education can help increase students' motivation and understanding, especially for abstract concepts that are usually hard to explain using traditional methods. So, this supports the idea that animation is useful for topics like states of matter, which are difficult to observe directly. The second study is by Putri and Al-Furqan in 2023. This research focused on Islamic education at the primary school level, and it also showed that animated media helped improve students' motivation to learn. Even though it is a different subject, it proves that animation can be a powerful tool to make lessons more engaging for young learners. The last study is by Platzer et al. In 2020. According to their findings, animation is more effective than static graphics when students need to understand how something changes over time. So this is especially relevant to my topic because states of matter involve changes like melting, freezing, and evaporation, which can be shown more clearly through animation than still images. So, in conclusion, all three studies support the use of animation in education, and their findings were very helpful in guiding the design and development of my application. To support the development of my application, I have reviewed and compared several existing educational, which is two existing educational applications to identify their strengths and weaknesses. The first application is States of Matter by Tiny Bob, has a clear focus on the topic of matter and how it changes with temperature. The content is very specific and well aligned with the learning objective for Year 5 science. In terms of user interface, it uses simple icons, clear text, and has a minimal and clean layout, which makes it easy for students to use without feeling overwhelmed. For the user experience, the application includes a temperature slider that is very easy to control. When the temperature changes, immediate visual feedback such as melting or freezing is shown, helping students clearly understand the changes in states of matter. However, one limitation of this app is that it lacks direct or explanations or guidance, so younger students may need an adult or teacher to explain what is happening on screen. It is more suitable for discovery learning but may not support independent understanding. The second application, which is how it works by Learning offers a wider range of science topics, including plants, energy, volcanoes, and the water cycle. So this application explains this phenomena using interactive animations, short explanations, and educational games. Its user interface also uses simple icons, large visuals, and minimal clutter, which makes it visually engaging and suitable for young learners. In terms of interaction, this application provides hands-on animation, audio guidance, and mini games that allow students to explore and experiment while learning. However, the weakness of this application is that the content is too general and not focused specifically on the topic like states of matter, which is children. Some parts may also feel more like entertainment than deep learning, and it may not align closely with the school syllabus in Malaysia. In conclusion, Tiny Bob's application is more focused and science specific, while Learning Lens app is more broad and playful. But however, both applications give me valuable ideas on what to include and what to improve when designing my own education animation application. For methodology, I chose AD model. So why did I choose this AD model for my project? Firstly, AD model offers a complete and structured approach. As this being said, AD focuses on both app developments and teaching methods. AD also ensures careful planning in all development stages. Moreover, each phase of AD helps improve the learning application. So there are five stages in AD model, which is analyze, design, develop, implement, and evaluation. In conclusion, AD model follows a clear step-by-step process and can be adjusted to suit different project needs. It also matches the goals of the 2D animation application. During the first phase of AD model, which is the analysis phase, I started by interviewing a science teacher in SK Sribetam in UNT, which is Puan Hazli Nadira. So I asked her about the problems or challenges she faced when teaching the subtopic of GRAM. From this interview, I got useful insights about what makes it hard for students to understand the topic and what kind of teaching methods may not work well with this topic. Then I continued with the three types of analysis, which is user analysis, needs analysis, and task analysis. For the user analysis, I researched who is my target users are. I looked at what kind of devices my usually have, which is the year 5 students. This helps me understand how to design my application to suit the devices they are using, like smartphones, tablets, or laptops. Next, for the needs of analysis, I have identified the software and hardware I would need to create this project. I also listed what devices are compatible or can support the application I am developing. So this helps make sure my application can run smoothly on the user's devices. And lastly, I did a task analysis. For this part, I studied how to deliver each subtopic effectively. I started by identifying the type of knowledge in each part of the topic. Based on the type of knowledge, I selected the most suitable instructional strategies to help students understand better. Uh, Second, in the design phase, which is the phase two, I worked on four key parts, which is the user interface, UI, user experience, UX, or an instructional design ID, and the storyboard. For the user interface, I decided on the type of font size, text color, and overall layout to make sure everything is easy to read and visually suitable for students. In the user experience section, I planned how users will move through the applications. So this includes the navigation buttons like home, button next, and back button, and the structure of all the pages so students can explore the content smoothly. For the instructional design, I chose what content will be included and how it will be organized and what multimedia elements I will use, such as animations or voiceovers to make learning more engaging. Most importantly, I created a storyboard. The storyboard shows a visual plan of each scene or page. It combines all the user interface, user experience, and learning content ideas into one clear reference. So this storyboard is very helpful in guiding the development process in the next phase. The third phase is phase development phase, which is firstly, storyboards will be designed for the visuals and arrangement of elements in the application. Secondly, I will develop 2D animations using Adobe Animate. Then, graphics for the application, such as navigation buttons like back button, next button, will be designed using Adobe Illustrator or Adobe Photoshop. Then I will integrate all the animation videos into Adobe Animate to be included in the designated subtopics. The fifth step is the narrator's voice will be inserted into Adobe Animate and at the appropriate part of the animation. And lastly, use user control coding will be done in Adobe Animate using ActionScript. In the implementation phase, which is the phase 4, I tested the full functionality of my animation, which is the application. This is to make sure that the application works properly on real devices before exporting it as an APK file, which is used for Android devices. During this phase, I carefully checked all the components in the application. For example, I made sure that all the buttons are clickable and that they navigate to the correct interface or page. I also tested the overall performance of the application to make sure it runs smoothly without any major issues. Once everything was working well, I exported the project from Adobe Animate into an APK file. After that, I selected a few students at random to test the application using their own devices. These students were asked to use the application from beginning to end, including completing the quiz section at the end. While they were using the application, I will I observed how they interacted with it. I looked at whether the application was easy to navigate and whether they could complete all the activities without confusion. I also took note of any technical problems they faced so I could use that feedback to improve the application. So this phase helped me ensure that the app is user friendly, functional, and ready for real classroom use. The evaluation phase is the final stage in the AD design model. So the main goal of this phase is to evaluate the effectiveness of the application and ensure that all functions work as planned. For this project, the evaluation focuses on the functionality of the system. This is important to make sure every part of the application runs smoothly and supports the learning objective that I set in the earlier. The evaluation was carried out by 6 experts, which is 3 lecturers from the Faculty of Technical and Vocational Education, which is FPTV, who specialize in creative multimedia, and 3 experienced science teachers. The main focus of the evaluation was on functionality testing. This type of testing is important because it checks how well the application works and whether it performs correctly in real life. Their feedback helped me confirm that the application is both functional and relevant to the learning goals. Next is product design. For product design, I focuses on 3 keys, which is design of content, design of interface, which is user interface, and third is design of interaction, which is user experience. For my for my design of content, 8 out of 9 Gartner's events of instruction were applied, which is gain attention, inform learners of objective, stimulate recall of prior learning. The fourth is present the content, provide learning guidance, elicit performance, provide feedback, and assess performance. Next, as for my design of interaction, which is user experience, I have applied 9 out of 10 of Nielsen's heuristic principles, which is the first one is match between system and the real world, user control and freedom, consistency and standards, error prevention, recognition rather than recall, flexibility and efficiency of use, aesthetic and minimalist design, help and documentation, and lastly, visibility of system status. Lastly, for my design of interface, which is user interface, 5 out of 8 Schneiderman's golden rules were applied in the development of this application, which is strive for consistency, offer informative feedback, reduce short-term memory load, design dialogue to shield closure, and lastly, permit easy reversal of actions. As for storyboard, this is my main page. As you can see in this page, I applied Gartner's 9 event instruction, Schneiderman's 8 golden rules, and Nielsen's 10 usability heuristic. I applied Gartner's 9 event instruction, which is gain attention by using a simple cartoon and playful color to attract young users. So this page also uses aesthetic and minimalist design, which means they do not clutter. The icons start also applies in Schneiderman 8 golden rules, which is reduce short-term memory load by using direct language. For the next page is my subtopic page and main menu page. For these two pages, I applied Gartner's 9 event instruction, which is gain attention, Schneiderman's 8 golden rules, strive for consistency, and permit easy reversal of actions. As you can see, these two pages has buttons, which is exit button and home button, and these two buttons stays at the top or bottom of the page. And users can easily click on the home button to go to my main menu page. And the third is Nielsen's 10 usability heuristic, which is user control and freedom, recognition rather than recall, and flexibility and efficiency of use, which is user can freely control this application by clicking on the back button, clicking on the menu button, or clicking on the sound button to mute the sound. And all these buttons are using a simple icon, so user can recognize it easily for first time user or a frequent user. Moving on, these two pages are user's guide and learning objective. As you can see, these pages are designed with the same graphic, which is blackboard, because these are pop-up pages. This can be related to strive for consistency and inform learners of objectives. Nielsen's 10 usability heuristics are also applied because help and documentation are present, which is the user's guide pop-up. So the next pages is the pop-up messages when user click on the exit button on any page. So these pop-up messages will show up to make sure user make a right decision and not just accidentally clicked. So these pages applies Schneiderman and Nielsen principles, which is offer informative feedback, prevent errors, permit easy reversal of actions. For Nielsen's 10 usability heuristics, it applies user control and freedom, error prevention, match between system and the real world. So these two pages are the prototype pages of first subtopic in my application, which is Pepejar, Cahaya dan Gas. As you can see, there is a play button, pause button, and next button. So user can freely decide whether they want to continue watching the video or go to the next page. All these buttons in these pages are using a simple icons which user can recognize quickly, even for a first-time user or a frequent users. And the buttons such as exit, home, and sound settings are still at the same position as previous pages. So there is there is Gartner's, Schneiderman's, and Nielsen's principle are applied in these pages, which is for Gartner's, gain attention, and present the content. For Schneiderman's, strive for consistency, reduce short-term memory load, and Nielsen's, user control and freedom and recognition rather than recall. Lastly, these two pages are curated to assess students' understanding, which is the quiz page and the quiz score page. On the quiz page, students can view their current score, which is the box at the right bottom. So this reflects the principle of offering informative feedback by Schneiderman's 8 golden rules. And Gartner's 9 event instruction were also applied, which is the assess performance, provide feedback, and elicit performance. On the quiz score page, user can also choose to redo the quiz or back to the home page. This reflects the Nielsen's principle, which is user control and freedom. For the expected outcome, I hope this application will help students better understand the topic of states of matter through clear and interactive animations. It is also expected to increase students' interest and motivation in learning science as the visual approach is more engaging compared to static textbooks. This application can also serve as a useful teaching tool for teachers, especially when explaining concepts that are abstract or hard to visualize. In addition, by presenting information in an easy to follow way, the application can help reduce misconceptions and promote independent learning, whether at home or in the classroom.